Well, I'm going to do something today. We've never accepted one of these for repair ever before, and it's the Catswhiskers Cat Call, which is a DNT recased in the UK with some selective calling system, and it's another one of these was the Westwood PT2. It isn't another set; it's a Maxcom 4E in that case, recased and shoved in with a battery. So I don't like these kind of abortion type sets. So these are difficult to. I said to the customer, "There's nothing I can do with your selective calling stuff. We've got no information on it, so it can't be aligned. So if you're expecting that to work, there's absolutely nothing we can do." But what we can do, of course, is to service the radio as a normal radio, and it's come with a cigarette power lead, which is about good for half an amp. So yeah, that's going to restrict the output. But yeah, it's going to be a DNT. I think it's a super tuned version of the DNT. And this only came yesterday, and we have a 28-day turnaround on CB radio because it's very down the priority list here. But I want this out of the way, to be honest. Allegedly, it's got no transmit, and that can be down to a chip on these. Put the soldering iron on. So as you can see, we've got a DNT. And if I put the other glasses on, I might be able to see if it's a super tuned version. Yes, it is. We've got the crystal filter there. So like that awful, what was that awful set I did the other day which took ages, multiple transmit faults, was it Team TKR2002? It has a 3 crystal mixer arrangement for the synthesizer, so again it has the Motorola MC wherever it is, general purpose synthesizer. That's not there. Where is it? It's here. It's this one, 145106. So it has its 10.24 reference oscillator. It then has a crystal mixer for receive and a crystal mixer for transmit, and so you can end up with no transmit for several reasons. When the phase lock loop's out of lock, it sends an out of lock signal, so the radio will not go into transmit. So this could be why this customer has got no transmit, because it's out of lock. Having said that, the 4011 gate chip here, TTL gate thing, that can fail because of static sensitive. We've got a subboard here. What's that do? No idea. It's got a hefty transistor on it, so tip 41. Is that a horn honk relay? I don't know. Right, we'll disconnect the speaker. And we're going to end up having to take the bottom cover off because we're bound to have to do some soldering. These radios do suffer from dry joints, and did right from the word go. Like one or two other sets where the boards aren't plated through, like the grandstand base station, for example, where you've got that IF and VCO in a huge can filled with wax that you do little with. You've got a lot of points where the components are soldered through, and it relies on the cleanliness of the wires on the leads, both sides, for that to work. And so we started to see returns within days back in 1981 when the DNTs hit the streets, and it was dry joints. It was nearly always on this component side of the board. Oh, this is going to be a laugh, isn't it? So we have to take this chassis out to get to the other side of the printed circuit board. Oh dear. So that's the normal catcall printed circuit, and then on this one we've got whatever with a tip 41. No, haven't got the foggiest. And the aerial socket is moved to the front of the product. Now, in this coronavirus situation, we're asking customers not to send mics, so I will have to see if I can borrow a mic off another DNT, or we'll make one up specially. Well, we'll start by plugging this cigarette lighter in. And I'll plug the test instrument into the antenna socket. So if it lets us go into transmit, that's going to be novel. We're going to start by trying to set the at 10.24. Right, we shouldn't be showing that one. We should be showing that one. But then we're not even on picture in picture. So I'll see if we can. We've got some power on the radio. We have. It was on 19 for whatever reason. So that should be. Can you plug an extension speaker into these? Oh dear, no you can't. So we'll have to crocodile clip our instruments onto the speaker lead. Shouldn't need a mic on these to I don't know which is positive and what. No, I'm at a loss. Don't know how we get any audio out of that, but I will make up a mic. Okay, I'm sure the customer said this was no transmit, but I've got no receive either. So I've got no hissing of FM apart from very low level. And I've got the signal generator on channel 20 and the radio on channel 20, and I've still got that very low level hissing, so it's not receiving either. And I've given it a few bangs in case it's dry joint. So the first thing we're going to do is monitor the 10.24 from the synthesizer's oscillator, so hopefully we can do that. Pin 4, 10.2386. So we need to bring that up or we're going to get nowhere. Of course, I've got that with the wrong hand, so I need to put that there. So we have 10.2386. Hey, we've got 10.24, which is a damn sight better than we had on that thing yesterday. So that's the crystal oscillator set. That won't suddenly bring transmit back. So I'm going to have to dig out the circuit diagram. We've got no transmit and we've got no receive. So the only thing we know that's happening is the amplifier's working, because I can hear it at low level, and I've no doubt this is if I put something on the volume control, like my finger, we shall hear something. No, I'm wondering, how is this thing woken up? You know, I do not know. Is it always in a muted state until it receives a cell call, or is it faulty? It's certainly not receiving 2779125. So is that linked? Is there like an 8-volt rail in these sets which is missing? So we're going to have to dig the circuit diagram out and see. Okay, well, we've moved forwards on this. I had to email the customer and say, look, do you need any of this cell call stuff? Because one of the faults is in the cell call. We've got no transmit, that's one of the cell call boards. And the other one is still in the bottom but now disconnected. And because your transmit line goes through the cell call board, one of the reasons why there was no transmit is because of a fault on the cell call board. So we've now rewired it as standard, eliminating cell call board, and we actually have some transmitted audio. So if I listen on our monitor receiver, testing 1 2, testing 1 2. Obviously we'll set that up in a bit. One of the things which I do need to do, which is what I was trying to do in the first place, was to set the frequency. I don't even know that because the microphone plug goes to the cell call board and it doesn't now, I've wired it as standard as DNT. But whether or not it was wired like that, and whether the customer's mic will still work with this without being wired standard, is another guess. Because the earth goes through this bottom chassis, I really need a crocodile clip onto the chassis with negative on it. So what I want to do is we'll get it on frequency first. I'm very far away from having any receive. You know, it may not be repairable, I don't know, but at least we've set the 10.24 in the beginning and we now have transmit. So if we look at the transmit power, I'll go to the 3 watt scale. We actually have 3 watts, so yeah, it's about where you'd expect. So what I need to do is to set the frequency. I just need to remind myself which is the transmit frequency one. And the clue is on the block diagram. And it says TX oscillator 11.6806. So TX oscillator So 11 point is the transmit one, so it's CV3. So 11 point, so look at which crystal's which. And the crystal on the right is going to be the transmit mixer. So, I don't normally have this much clutter on here, but with all these extra instruments needed for sets like this, we'll go over to the frequency counter and let's have a look. So we're looking for 2779125 and it's low. So there we are, 2779125. So we know the 10.24 is correct, we know the transmit's correct. So now we'll just go about the normal transmit tune-up. And obviously we've got those three there. Just think there's one earlier as well. So they're called L9, L10, L11. Nine, 10, 11, and then we've got probably L16 and L15. So L16 and L15. So 9, 10, 11, 16, 15, 16, 15, 16, 15. Right. I'm sure these were set up right by Catswhisker, but we'll just check. Yes, that's definitely peak, so that was fine. I'm sure this is going to be just as fine. Needs to be a bit more melted than that. That's still too tight. Yes, that was spot on as well. So we'll just do those three there. If they're on camera, I'll just move the camera across because I'm having to work towards the left because of all the test gear required. Which camera is it? I'll tell you what, we'll put that on 1. And if there's one down there, it'll be the 54 meg trap. It's got about 3.5 watts. So we put that on the 3 watt scale, it's right across. If we put that on the 4 watts, on the 30 watt scale, it's approaching 4 watts. It's not that far out, and it has been transmitting now continuously. So we'll look at the deviation. I'll also have to remind myself which the deviation is. Probably a resistor 84. So what we've got, that's 136.84. So we'll get the little audio oscillator out. I really ought to, instead of tuning this up, I really ought to be getting the receive sorted, because this may be a waste of time. Now it's over deviating, which is a shame. It's 2.1. Let's see whether the oh, that's now spot on. Brilliant. 2.2, absolute maximum of 2.5. So we've got that. So the transmit meter, so low power's been disabled on this radio because it's got that stupid sleep switch. So resistor 136 would have been low power. Transmit meter looks to me to be 98, and 98 is that one there, which is low, which has been replaced with a higher quality than original. So we now should have, well, we'll have it so that it's reading 4 on the screen. That's my crocodile clip gone off for power. So it's the lower one. So we're going to transmit, and we've got that nice in the centre of the red zone. Good. Now we've still got no receive. So I'm going to have to see what's been disabled, because some of it's going to go through this printed circuit here. I'll tell you what, we'll take that out, because all we're doing is dragging it around, and cut the wires to the sounder. I'll put those back in a I'll put them in a plastic bag for him. So we've got less clutter in that bottom chassis now. Right, well, I'll see whether we can get anywhere with the receive. So go back to switching the camera off. So going back to record, only minutes later, I found that having taken all the cell call junk out and put some of the links back which were obvious to me, I do now have receive. We can see it on the meter, and we can hear it at tiny volume. So if we look at the sensitivity, mind you, it's not it's not that brilliant. Oh no, that's S9, and it is S9. I'll tell you what, I'll be silly and I'll set that up. Especially if I put the crocodile clip back onto the chassis. Oh, that is a pain. So it's the upper one of the two there, and that's spot on the S9. So as we take the signal generator down, that's 1 microvolt. I can still hear it, and I might be able to just about hear 0.3. So it is receiving now, and all we've got to do is somehow route that audio properly through the amplifier. Yes. So roll on many more, because I've done other things, and we've now got audio, and so I thought I'd got all the links right, but it turns out we've got a Duff audio chip, which is TDA2003 on these. And I must admit, I pinched one off a scrap DNT chassis, which I've been using as a pattern to get the wiring back to where it should be for factory standard. Now that sounds off frequency, of course it does, and once again we're going to have to use our little Chinese thing as a marker oscillator. So I'll take the tone off, just show you we've got on the frequency counter, we've got 2779125, that's what you're listening to. I'll take the tone off. Now we've got a hiss, turn the volume up. So you know you've got that. That's 1 microvolt. That's 30 microvolts. So we now will, in fact, we'll switch picture in picture off. So we'll just dial in the frequency we want into this. If I can see it. So we want frequency of 10.6 9 5. Now we'll trim that with the trimmer. And that's the radio now on frequency. Tone back on. And it still sounds absolutely horrible. Perhaps it's an absolutely horrible radio. So I think we've done with the multimeter. Put that away. So now we're going to put a bigger signal on the signal generator. That's now 100 microvolts, S9 equivalent. And we're going to look at the oscilloscope. And if I can find the detector, looks to be, well, it's a different technique to a lot of sets. It looks to be L5, but it could be L4. L5 is that one. Let's have a look. Yeah, it is. Oh, this is weird. You know what? That's as if super glue's in there. Just turn the volume down a bit. Never thought I'd say that on this set. I'm going to do that in conjunction with the synab meter, I think. Now it's not very sensitive. At the moment we've got well, actually it's better than I thought. It's about 0.75 microvolts. So I'm sure it can do better than that. So we're looking at L2 and L1. So that's L1, L2. That's L3. I can't actually see what that does. No, well I can't see it, so I'm not going to touch it. Now why are these out? Because they've filled them with wax. Well, you know what? Let's be stupid and touch that one. Nothing like wrecking a customer set. No, it was at optimum. So what have we got now? .51 for 12 decibels, so that's an improvement. I can't understand why those are out, because if they wax sealed them, surely they were right when they did them. Or, of course, I'm using a cyanide meter. Didn't they have a cyanide meter? You know, these are the questions. I think we're there, folks. So we've already set S9. I'll just touch that up a fraction. And I'm just going to now plug the aerial in. I don't normally do that till we've put the radio back together, but under the circumstances there's a lot to put together, and I just want to see if I can hear what anybody sounds like when you've got a set with so much wrong with it, and I've got so much junk on the floor. I genuinely had a cleaning lady and she died. Right, let's plug the aerial in. Now we've lost the earth because we've unplugged the test instrument, so we'll put a physical earth onto the extension speaker. And see if we can hear anybody. Plug the mic in. 19 Roger.
Outside bit, it just goes off fucking wandering.
Well, it works. So just go back to, there's one thing I need to do. I bet you've been shouting at your computer. That's the squelch, isn't it? If there is a preset. Yeah, there isn't, is there? There's no preset squelch. So we've got S meter, RF meter, deviation, low power if the radio still had it, that's it. Okay, so we'll see how it works. So I'll put the squelch to full. And we'll turn the signal generator up. It's 100 microvolts where it should come in. Comes in at a bit more than that, so that's not too scary. Now we'll do the test at the opposite end. I'll switch the signal generator to standby, and it's on 0.3 of a microvolt when it comes in. We'll set squelch to threshold and on. So it's disappearing off at about 0.2, coming in at 0.5. So yeah, I mean, I've seen more sensitive squelchers, but you know, I've seen more sensitive radios. So there we are. And this is heavily modified receiver, because the ordinary DNT M40 was a bleed over box. Now the DNT Super Tune version was redone by Cleartone, the two-way radio people, and they were supposed to be really half decent. And we've tested one of those, but we haven't started doing adjacent channel rejection figures yet, because it's too cold in that workshop to set up the second signal generator. It's -1 out at the moment, and there you go. And that room, you see, I'm in the middle of nowhere, and you're relying on electric heating, so you know you've got heaters in one room and heaters in another, and all we've got in there is something just to take the chill off. So it's about 6 degrees in that room. So I'm not going to go in there till it's at least 12 degrees, to be honest. Right, so that concludes it. We are there. And this has had a similar kind of thing done to the receiver, but when you actually, I'll turn the radio off because I'm going to disturb it, but when you look underneath, it's a right rat's nest and all around here. So you know, I'm not touching it. I'm not even going to go over with the isopropyl alcohol, except in that little corner where I've done the audio IC, because and there's corrosion here. It looks like this corner of the radio has actually been underwater at some time. So I'll tell you what, we'll just do that. But there's so many components tacked on the back that I'll just do that so I can inspect where I've soldered. But I haven't soldered really anywhere else. So I have detected one or two dry joints and I've dealt with those. But these sets were always prone to dry joints. So the thing I need to check with the customer is how his mic's wired. If you have the DNT, let's just zoom in on this. If you have the DNT, we're on diagram 11. It's that wiring. If you have the LCL 2740 or the even the economy or enterprise, it's this wiring. And if you look, pin 3, which is the extreme right, is transmit. Pin 3 is also TX. The audio from the microphone inside the microphone, does that make any sense? The actual microphone capsule inside the microphone goes to pin 1. That's always the screen lead. It's often yellow, and it also goes to pin 1. But look, on the DNT, the screen, the earth, so the audio screen, the braiding, goes to pin 4, which is the second from the left, and that's looking at the pin. I haven't got one to show you, but it's as if you've got. I'll just pull this out. You're looking at it like this. You're not looking at it like that. You're looking at it like this. Actually, looking at where you're soldering. That's how that's shown. So the difference is pin 4 is the screen on the DNT, and pin 3 is the screen on the LCL. And I've got because all the wiring from the mic went to the cell call boards, I've got a sneaking suspicion that 1 and 3 are transposed. So the customer's going to have to check how his mic's wired. And I deliberately told him not to send the mic in. I'm sure I did because of this COVID situation, because we're having to put disposable gloves in and put mics in the dishwasher. So, there's only one thing we're going to do, and I'm going to put the bottom on this, and we're going to give that time to dry. I'm just going to pop it on the spectrum analyzer, but there's not going to be much I can adjust. And I don't think these were sets which were prone to being a spurious emission set, and it's not like the screwdriver person has kind of tried to turn it up and failed. I mean, these won't. You would never dare touch one of these, because after all these modifications, and they're all legal you're quite entitled to put selective calling onto a radio. It's not like somebody's trying to screw extra channels or extra power out of it. It's quite legitimate, but it's a bit of a. I've never taken one on before, but it's locked down, and it's something different for the customer, isn't it? So you can see. Can you see this corrosion on this corner? And it actually goes through that corner like that. It's as if it's actually been underwater. It's probably been in a car that's been for a little drink in the ditch. But it's only affected that corner. And is there a filter? There is. So there is a filter under there, under that screening can there. So just get that in camera shot. You've got the relay, then you've got that screening can. There is an adjustment down there, so we'll be checking that with the spectrum analyzer. So come back to this in an hour, and we'll do just that. But what I can do in the meantime is to button this up. Okay, so we'll move over to the spectrum analyzer if I can find the remote for the cameras. So key up, there's our 27 meg signal. If we move along to 54 megs, oh, that's interesting, we've got 105 there. right in the middle of aircraft band. We've got nothing on 54 anyway. So what I will just do, see if we can adjust this into the power meter. No, that's fine. Still doing 3.5 watts, so we'll do an on the air test later on. And thanks for watching the Catswhiskers CW1580P, which is really a DNT in a box with some awful circuitry, which in this case, oh, that's where the speaker is. We'll go back in a plastic bag to the customer, and there's definitely, I mean, fancy not defluxing that. That's unbelievable, isn't it? And this radio has clearly been underwater.